I can't get the integral of this problem. So here we have this function, and we are going to compute this integral. And in fact, this integral is going to compute the arc length of the curve for us. So how are we going to do it? Firstly, though, there are two ways to do it because our function is actually pretty nice. If you look at this right here, it's actually a circle with radius of 5, and the center is at 5, 0. So just real quick, if you look at the graph, the center is at 5, 0, and the radius is also 5. So you have the semicircle here because it's just a positive square root. That said, though, the radius is 5. So the half of the circumference is just half times 2 pi r, and r is 5, so they cancel. So the answer right here should really be just pi times 5, which is just 5 pi. So later on, when we compute the integral, we should end up with 5 pi. Now let's take a look. Firstly though, before I take the derivative, I would like to simplify the inside a little bit, and to do so, we just have to multiply this out real quick, and that's going to be x squared minus 2 times this and that, so that's minus 10x, and then plus 25. And then we will have to subtract it, and that's square root, so we have 25 minus x squared plus 10x, and then minus 25. And that cancel, and let's actually put this down first. So that's the same as square root of 10x minus x squared. Okay, this is our function. Let's go ahead and get the derivative. I'll put it down right here real quick. The derivative of a square root is 1 over 2 times the square root of the inside. And then use the chain rule. We have to multiply by the derivative of the inside. The derivative of 10x is 10. The derivative of minus x squared is minus 2x. And then we happen to be able to reduce the 2 and also that. So reduce that real quick. So that will be 5 over 2 is, that's the answer, 5. 10 over 2 is 5, and then 2 over that is cancelled. And we have this. Now I'm going to put that down right here into the integral formula. So we are going to get the integral from 0 to 10, square root 1 plus parentheses with 5 minus x over square root of 10x minus x squared, and then square that dx. And we just have to work this out. Firstly, let's look at this. Square root cancel, so we have the denominator just 10x minus x squared. Then the top is 5 minus x squared. Expanded, we get 25 minus 2 times this and that, so that's 10x, and then plus this square, so plus x squared. So that's the expansion for that. In the front here we have a 1. Well, we have to combine them, and to do so, we need to get the common denominator. So let's multiply this by 10x minus x squared, and do the same on the top. And then remember, we are adding them up. So all in all, we have the integral from 0 to 10, a big square root. On the bottom is 10x minus x squared. The top is really just 10x minus 10x, which is just 0, minus x squared plus x squared, that's also 0. We just have a plus 25 on the top. Quite nice, huh? And then I'm going to put down this right here. That will be the integral going from 0 to 10. Square root of 25 is just 5. Over square root of that, I will have to keep it. That's 10x minus x squared. And now imagine that this is the integral that you have to do from scratch. How would you do it? The answer is you will have to complete the square for this. But in this case, we don't have to do so because we can just look back here, look back here, look back there. that form is preferred when we are doing integral for that. So I'm going to rewrite that back. We have 5 over, the bottom is really just the same as square root of that, which is 5 squared minus x minus 5 squared. Now, how are we going to do this? Two things. The first thing is that we have to know the following. Note that when we have an integral of 1 over square root of some number, let's say a squared, minus some variable, let's say u squared, let's say we are in the u world, we are going to end up with the arcsine situation. This is the arcsine of u over whatever the a is, and then plus c. In this case, we don't have to put down the plus c because it's a definite integral. So in this case, you can see right here, we can just put u equal to x minus 5, and du is the same as dx, which is very nice. And then the a in this case is just a 5. You can see the a is really just a 5. So now, this 5, I will just write it down right here. And then the rest, I'm just going to use this formula. We will end up with inverse sine of u, which is x minus 5, over a, which is 5. Whew. And then let's go ahead and plug in numbers. I'm just going to go from 0 to 10 because I'm still in the x world. Okay, 5 inverse sine. When you plug in 10 in here, 10 minus 5 is 5. Over 5, we have 1. So this right here becomes 1. Minus, plugging 0 into here, we still have the 5 inverse sine, and that will give us negative 1 once we plug in 0. Yeah, I don't have enough space. But anyways though, I will maybe just write this down right here real quick. Inverse sine of 1 is positive pi over 2. And then inverse sine of negative 1 is negative pi over 2. And in fact, you could have done the following because it's symmetric, but just do a computation, it's easier anyway, right? So you have 5 pi over 2 plus 5 pi over 2. So altogether, we do end up with 5 pi. Just like that. Hopefully this helps. That's it.